Oh, all right. We're on this window. Hello, my dudes. How's it going, my dudes? So yeah. Now this is part 2 of 8-3, right? I think that's 8. Yeah, 8-3, my dudes. So, yeah. So, we're on geometry, a little geometry thing. You know, we're on a patio, all right? So, we're looking at a patio. So, a patio in the shape of a triangle shown is being built in whatever person's backyard. The dimensions given are in feet. The area A of the triangle is 1/2 the height h times the base b. Write an expression for the area of the patio. So we have two different things right here. We can just put those in little parentheses just to make it a little bit easier for y'all to understand. So it's pretty much what we've been doing this entire time, only we know if you know how to get the area of a triangle, it's going to be base times height, but then divided by 2. So that's our question. That's our equation right there. It's just base times height over 2. Now, we just got to figure out what our base and what our height is. So,
I gotta tell you one thing.
oh,
In algebra, what's the one thing that's gonna irk me about that?
the
That
multiplication
portion.
symbol?
Yes, the multiplication symbol. In algebra, we
Multiplication
do
symbol.
not use.
In algebra, we do not use the multiplication symbol from what I've just been told.
We
So,
use a multiplication symbol, but what is
it's
the
a
multiplication
dot
symbol?
or it's parentheses.
Or a star?
I'm going to do a dot.
Okay,
Is
cool.
that cool? All right,
Yes.
cool. So yeah, we're gonna do a B and then a dot for Miss Dominguez. There you
Awesome.
go. All
I'm
right,
so happy.
you're happy, Miss
I'm so
Dominguez?
happy.
Cool, great. All right, so B times H over 2. Now we just gotta figure out B and H. So the base is the bottom of the triangle. So we already got that right here. So if we just plug that in, now we would have 6x plus 4 times H. But then we need H. So H is just right here. It's right there. It's going up. So you got the height right there. So now if we just write that in, we have 6x plus 4 times, we'll just do parentheses. Uh, I'm going to have to erase that and move it down because I don't have space. All right. So let's move that down a little bit. So we have 6x plus 4 parentheses, Then you got next parentheses, you got x minus 7. And there you go, guys. You got that little thing over there, and you put that over too. So we already have an expression, really. We already have an expression, but just to be extra, because that's me, we're gonna solve it real quick. Because why not? Is that fine?
You're gonna use the box?
Yeah.
Okay.
All right. So let's just use the box method for this, just to be nice to everyone.
Okay.
So we'll have 6x, because that's one of our first terms. 6x and 4, because that's our second term. New parentheses, new side. We have x and negative 7, because remember, sign stays with that number. All right. 6x and x, that's just going to multiply, and you're going to get 6x squared. So we have that. Now we're going to go on to the like terms. 6x and negative 7. 6x and negative 7 will multiply to get 42, negative 42x, if I'm correct, because yeah,
Let's see.
neg
Negative 7 times 4.
negative
Oh, never
42?
see. Yeah, you're right.
Yeah, negative
Negative 42.
42x. All right,
Uh-huh.
cool. Then we have 4 and x, and that's just 4x. So we're good on that.
Okay.
Then we're going to move on to the last one, that last little box. And we already have our like terms that are diagonal from each other. They're besties. They can't be too far apart. And then you got 4 and negative 7, and that's just negative 28. So you got all of that. I That is very off. I won't worry about that though. So that's a 2, guys. Just so you know, I made it better. All right. So we have negative 28, the 6x, all that. All right. Now we just got to add that all together, everything in that box. So we already know 6x squared is by itself. 6x squared is by itself because it's a loner. It doesn't have any friends. Nothing's like it. It's a lone, all right? And it's going to be forever that way. So then we move on to the next one. And that would be a negative because the negative number right there is definitely a little bit higher than the 4. So we're going to subtract 4. Well, add 4x to a negative number, which is negative 42x. And we're going to get a negative 38x right there. And then minus a 28. It's cutting it a little bit close right there. Now, that's pretty much the top part now. So now that's literally all just hovering over that 2 right there. That's 6x squared minus 38x. I messed up my 8. I'm just going to do this. 38x minus 28. I I'm good at this, guys. I'm a professional. Professional. Minus 28. All right. So we got all of that. Probably. So I'm going to extend that page. All right. So we have all of this up here. We have all of this up here, and we have that main equation. Now we're just going to divide that by 2. Is that fine if I divide that? All right. So we're dividing everything by 2. This is something I might need help on just to double check me. So we're going to have to divide every single thing up there by 2.
Absolutely.
So 6x would be divided by 2. So it would be 3x, just 3x.
3x squared.
3x squared, okay.
We keep the
3x squared.
Same. Only thing
Because,
is the coefficient.
yes, we're only dividing it by a normal number, because if we were dividing it by like maybe 2x though, on the other hand, that would get rid of the exponent.
It's going to subtract. The
It would subtract the exponent, sorry.
Mm-hmm.
So, we have 3x squared
Right.
minus, and that would be divided by 2. So we have 20,
I'm thinking 19.
oh, 19, sorry.
Okay.
19x.
Perfect.
And then we move on to the last one, which is 14 minus 14.
Perfect.
And that's our answer, really. We don't know what the x's are. We're never going to figure that out, ever, in
No,
your
you know
entire
why?
lifetime.
Do you know why?
Why is that? Why won't we
We
ever
don't
know
have
the
an equal
x's?
sign.
Because we don't have an equal sign.
If we had an equal sign,
Then maybe we'd be able to calculate the x's. If we had an equal sign, then we might be able to, or then we would be able to calculate what each x is.
okay, I'm gonna like interject one thing because I like to
Interject.
solve things multiple ways. So
Okay.
make sure you write this down, pause it. I'm gonna erase it.
All right. Yeah, write this
Okay.
down, guys.
And everything up into like, okay, we're gonna try that again. Bigger.
Yep.
Okay. And I'm gonna go based on this step right here. Okay.
All
Sorry
right.
if I get in your space.
So this is the
Right.
step she's talking
So
about
I'm
right
just gonna
here.
rewrite it. 6x plus 4, okay, times x minus 7. Yes? Is that what that is?
Yes. All right.
Cool. Yes?
Yes, that's
And
what that
then this
is.
is a 2. Okay. So just a thought. If you wanted to be a little creative, you could definitely do it that way. But you could just say, hey, I'm gonna divide this factor right here by 2.
Oh,
And
okay.
you could say 2 goes into 6 how many times? 3.
3x.
2
So,
goes into 4 how many times? 2, right?
so then you'd have
So you have
3x
the 3x
and
plus 2.
plus 2.
So now
Okay.
you've just got 3x plus 2 times x minus 7. You can use the box, you can use FOIL. If you're using FOIL, then you might say 3x times x, 3x squared.
Mm-hmm.
3x times negative 7, negative 21x. Pull the bottom distribution,
Mm-hmm.
plus 2x, plus 2 times negative 7, negative 14.
Negative 14.
These are like terms. 3x squared minus 19x minus 14, and we're done.
Wow. All right.
Just
So,
a thought.
yeah.
Just another way to do it.
So a little interjection by Miss Dominguez.
Yeah.
You can do it that way if you want. You can just divide the 2 into this instead of going through the entire other thing and getting the actual
Either
like
way
full answer.
works.
Either way works.
Do what
A
you
little
like.
quicker, yeah.
Right.
So that's a little quick way if you're trying to beat your math homework and get it over with so you can play video games or whatever kids do these days, you know. Um, all right, moving on. Next one. So this is not on there. This is not.
No, we're not doing that.
Yes, so we're not doing that one. That is something
Something else.
else. Yeah, that is something extra. All right, example 4. This is example 4A. Make sure to we're doing this on our notes. All right. So we have these things now. I'm gonna move it back to black. All right. So we have 3A, 4, and then we have a squared, 12a, and 1. Now, things might get a little bit tricky here because you're thinking, okay, well, it's just the same thing. That's exactly what it is. It's just now there's 3. It's literally just the same thing, only now there's 3 in one of them. The box method is still going to work here.
Yeah, let me show you what kind of box.
The box method will still work here. All it is, though,
How are we going to
is
change
just
the
going to
box?
be instead, since the second one in parentheses has 3, you're just going to add 3 little top rows. So you got
We have 3 what? In the second parentheses? 3 what?
we have 3 terms
Terms.
in the second parentheses.
Yeah.
So we're going to put those all on top. Since we have 3 separate boxes.
That
Or
is genius.
yeah, columns. So
Yeah.
we are good.
Oh, I like it.
Now we have first term, 3a. So we're just going to put that back over here. And the reason we didn't make this one 3 down is because we only had 2 terms in those first parentheses. So really you could do this box method with however many numbers. It's just you got to add rows and columns depending on how many you have. All right. So we got a positive 4. You can just put a 4. And you got, moving on to the next terms, next parentheses, so on top now, we got a squared, and we have negative 12a. Remember the signs. You got to make sure you have those signs. Negative 12a, that's off a little bit. That's an a, though, guys. All right, and then we got a 1. That's just a positive 1. So now we can multiply these. So 3a and a squared. This literally is just adding another exponent to this since you're multiplying the like terms a and a squared.
Yeah, because
So all it is,
have its own base.
each exponent has its own base. So that's an a1. So since you're multiplying that by an a2, you just add that a1 to the a2, and now you have 3a cubed. 3 means cubed, and yeah.
So a to the power of 3.
Yeah, a to the power of 3.
Right.
So then you got 4a squared, which is just going to be right here. And here's a little thing right here. Now we're going to move on to the next row, right? So this is still, you can still have like terms diagonal from each other. As long as there's able to be a diagonal, there's going to be like terms. More than likely. So we have 3a and negative 12a. So that's still going to be so that's going to be negative 36a squared. So those like terms are still diagonal from each other right there. So that's all good. Then we move on to the next one. We have 3a times 1. We'll just do a 3a because that's what it is. And then you got 4 times negative 12a, which would be negative, whoa, I just hit the smart board, negative 48a. And those, again, like terms, still diagonal from each other over here, you know. All right, so you got 3a, negative 48a, and then finally 4 times 1, you got a 4. Now you just got to do that like we've been doing and just add those all together. So since 3a cubed up here, or 3a to the power of 3 is just right over here. It's the only one that has a 3 or to the power of 3.
Hey, I just thought of something.
Huh.
Because these are like terms, right?
Mm-hmm.
These are like terms, like terms.
So those are like terms.
What
yes.
are the 2 things that make terms like again? They
So
have to have the same.
the only way terms are alike are if they have the same exponent
Yeah.
or same variable.
Okay, check. So this has got a and an A, right?
So you got
And
a and
it's
an A
got
and
two
a 2 and a
and
2.
two. So if it's got an A and it's got an exponent of two, we're like,
Yep.
right? Okay, got it.
So if two different terms have the same exponent or variable,
Mm-hmm.
or both, if
We
it's
gotta have
like,
both.
yeah, you got to have both if one has both.
Okay, then they're
So
like.
then they're like.
Okay.
So right here, this is the only one that's all alone, and it has a 3a to the power of 3. That's all good. Then we have the like terms. So we have negative 36a squared plus a 4a squared. And that'll just equal 32, negative 32a squared right there. And moving on to the a's, the a-like terms, that is also going to be a negative. The 48's bigger.
Mm-hmm.
So we have negative 48a plus d3, which will give us negative 45a. And that's all good. And then finally, just the plus 4 to add it all together. And there you go, guys. That's literally it. That's that huge problem.
That is a thing of beauty, such thing.
Yeah, so just so y'all know, y'all can use the FOIL method still. I'm not going to do that because that's that's a little bit too much craziness right now.
That would be, but I mean, it's not impossible. You
I
can
mean, it's
definitely
not
do it.
impossible, but I already did the box method. All right,
Yeah, perfect.
guys?
Okay.
The FOIL method, y'all know how to do it now. Y'all can do it the exact same way, only just a little example. If you're trying to do this with the FOIL method, you just write lines to each term from the other parentheses. So 3a times 2a squared times 12a and then the 1. And then same thing with the bottom one. You just go to all three of those. So if you're doing the FOIL method, that's all you have to do. Again, you can do it that way or box method, you choose.
We do for fun.
Yep.
You know, bored on the weekend.
Yeah, if you're bored and you need something to do, make up a random thing to waste your time. It's called math. I mean, nothing bad. All right, so
Okay. What kind of box are we gonna
now,
do?
guys, this is a good one right here. This
Or
is
you could
three.
do a box,
This
or you could do foil. I mean, foil's kind of fun.
so
I mean, it's
we're
up to
gonna
you.
do foil on this one
You could
because
do
I
foil.
love foil. Foil is my favorite, personally, my favorite
I do too.
method.
And if you stack it, it's not
So
that bad.
just to show you though, I will draw a mini box if you don't
Oh,
understand.
that's true. What kind of box would it
So
be?
this would be practically the same thing, only it would be a 3 by 3 grid because you have three terms in these parentheses and three terms in these parentheses.
And I will tell you that
Oh,
your like terms are going to be like right here,
like terms,
right
all three
here.
like terms,
Yeah,
and
and
then
then
two more like terms.
that's the pattern.
The diagonals
Yeah.
in the box plots are usually almost
Typically.
always typically
Yeah.
like terms. So
Typically.
you have those three like terms, and that's what we're gonna figure out while we're doing this on foil. So let me just erase this little
Use
thing right there.
whatever
Oh,
method you like, and
wow, that's
at the
amazing.
end, check your answer against questions.
Yeah. All right, you can check my answer if you want. You can pause the video, figure it out before me. Be flash, and I'll be super slow. All right, so we're gonna do FOIL method. So we got 2b squared. I should probably write this a little bit smaller. 7b plus 9. That's our first little parentheses right there. Then we got b squared and plus 3b. Oh, all right, and minus 1.
Now, I do have a request. You know how you
Okay,
like
she has a request.
pre-draw all your lines, right?
Yes.
I'm gonna ask if you would
So,
just draw like in a separate color for each term. So like
mhm.
for your 2b square, your first term.
Oh, so do a different color
Right, like just
for each
do
lines
for each turn, right?
or each term's
Just so
lines.
that we can kind of keep it straight.
All right, all
Yes.
right. So I'm gonna use the blue
Okay.
for 2b squared. We're gonna go across with the lines. So first one right there, 2b squared times 2b squared, or just times b squared. We're gonna have 4b to the fourth power
Perfect.
because all you're doing, since you're multiplying them,
Yeah.
you're just bringing the two. Oh wait, why did I do 4b?
You're right. You're
Why
right.
did I do 4b?
Ah,
I am. You're just bringing the exponents over and adding the
my
exponents.
fault. My bad.
My bad, actually. Yeah. All right. So we
Two
got
times one.
2b, yeah. So all it would be is 2. The 2 would go against the imaginary 1 that's right there, and then that would be 2. And then you have the b squared plus a b squared. So then you have, or I mean, times a b squared.
There you go.
So then you'd have 4, the 4 as your exponent. All right, so we got 2b 4 to the fourth power. That one's going to be by itself because that's our first one. Usually the first number and the last number don't have like terms.
Which are good
Usually.
techniques if you have a multiple choice question and you want to kind of
And
get a
yeah,
quick way to check to see.
if you're on a multiple choice question and you need something to double check, that's a good thing to look for.
Yeah.
If you see that there's something with like terms in the problem at the end, or that there's one that's like next to something else that shouldn't be there, you can check that really easily
Yeah.
because the first number and the last number usually don't have like terms. So that's good. All right. So 2b squared times the next one, that is a 3b. Yes, not a 36. All right, 3b. So 2b squared times a 3b. So that'll be plus, because that's a positive 3b, 6b cubed. And the reason that's that, because exponents, b2 times b to the power of 1, the imaginary 1 that's there, you get, multiply them, and you get 3. So you're good.
You add.
Oh, well, you add them, but
Mm-hmm.
you multiply them to even add them. So it's like,
Yes, you're
yeah,
multiplying, and so therefore you add the exponent.
yeah.
Got it.
All right, so we got that done. That that's the first one done.
Okay.
But we're not done with 2b yet.
Okay.
Now we're almost to the last one. The last one right here is negative 1. All right, I don't want to make sure I want to make sure I'm not going over time right here cuz that's a lot of,
Yeah, a lot of talking.
yeah, and
And checking.
a lot of stuff. Yeah,
Oh Lord. Um, let's just okay,
cuz this
we'll
is going
make
to be a
another
little bit
video.
longer.
Okay.
All right.
Good thing
So,
they can fast forward.
we're going to do a part 3, guys. Yay.
Yay. Woo.
Part 3.
Long day.